Introduction of analysis and algorithm. Introduction. What is an algorithm? Algorithm is a well-defined fitness sequence of the steps that solving a problem. It must always terminate and give the correction output. Example: receipt for booking and is a algorithm real life. Character of an algorithm. The five types. First one is input. Should accept 0 or more values. Output must predict and lead to the result. Definitions. Every step should be clear and uncontroversial. Fitness. It should finish in limited steps. Effectiveness. Each step should be basic and accessible by machine. Next one, algorithm for examples. So first one is algorithm, flowchart is a program. Algorithm, 5 steps start, read A, comma B, equals C, is equal to A plus B, print of B plus C. Next stop. Example problem, so enter the largest of 3 numbers. Example how to combination gives else from an algorithm helps to understand how algorithms are expressed step by step. The flowchart and programming. Problem solving using algorithms. Understanding the problem clearly. Decide how the problem will be processed in the array, graphics, and etc. Selected graphics, divide, conquer, crazy, and etc. Design the step-by-step algorithm. Preview corrections to ensure to the mistakes. Analysis efficiency in the time and space. Implement and the testing the code. Next one, computation programming types. Algorithm can solve the definition problems. Numerical combination, optimization, text processing. So one is number units, arithmetical starting number. Component arrange the grouping, objective, graphs and plots. Optimization, find the shortest path, max, preferred, and etc. Next, problem solving strategy. Breathe, force, try all possibility. Divide, convert, break into subproblem, solve the component. Describes, controls the reduce problem size step by step. Dynamic problem, store and receive the result of subproblems. Gray, make the best local choice. Human coding. Break gradually. Improve all the optimization, block trade when stock in increase. Next, fundamental of understanding algorithm efficiency. Efficiency is equal to time plus space. Time efficiency, how long it takes. Space efficiency, how much memory is used. Analysis in the needing effort, coding to save time and research. Next, time efficiency. Running time, difference and the input size n. The measurements of the counting number of basic operations like comparison, assignment, example, and the linear research. Next one, space efficiency. Memory used during expansion, the fixed part, considers programming code, versatile part, data structure, researching stock. Example, research requirements more space, stock frames. Next, analysis framework. Performance may vary, best case, worst case, average case, input and size. So best case is the input where algorithm runs fastest. So worst case is the input where algorithm running slowest. Average case, expect the programming on runtime input input size equal to n. N's value is the key measurement of analysis. Next example, linear search analysis. Best case, element found at first position is equal to the value is 0. So worst case, the element not found are at last position equal to n. So the algorithm average case element found will show we analysis them under big omega notation. The reference appears one worst case scenario. Example on the ON. So ON square. If runtime is a 2n plus 3, we shave ON used to must commonly in analysis. Other notation. notation used to describe the efficiency mathematically introduced machine. Specify detail helps common algorithm generally. The big omega notation reference to upper bound worst case scenario. Example ON. So if runtime is a 2n plus 3, we say that when used mostly commonly in analysis. The example diagram. So omega notation reference to lower bound best case scenario. Example linear search best case 55 is also 1. The example. The theta notation represents light bound both lower and upper bound. Example bound purple short run is equal to more than actually just a O comma theta. The next one is time efficiency. Transitive time efficiency. The 5 types of transitive. First one is transitive, reflexive, summarily additive, multiplicative. Transitive is the next one. Analysis of reserve algorithm used to research in relations. Example on the binary search. Tn equal to tn by 2 plus o1 is equal to o log n. Example 2. Merge short. Tn equal to 2tn by 2 plus o n is equal to 0 n log n. Recursive trees helps to visualization. Next one, summary. Algorithm step-by-step solution. Efficiency, time plus space, framework, best case, worst case, average cases. Ascending notation describes the growth ratios to non-receiving algorithm analysis mathematically. Next one is reference. Introduction to algorithms, camera to all AI. Design and algorithm of uneven event. Class notes, online research. Next topic, breath force and divide encoding. Covers you to design, analyze and algorithm which forces onto foundation problem solving strategy with force and divide to control. Introduction. Breath force is divided to control two classical approaches for solving computation problems. Breath force is a simple and straightforward methods where you divide to the control is more efficient and systematic representation. Both methods are applied to optimization, searching, sort and mathematical problems. The breath force is the breath force was attempted to solve the problems by trying all possible solutions until the best one were found. It very easy to design and corrections, but it is useful to influence backers, requirement checking and the exponentials to face factorial number of possibility. Next one is closest pair problems. In the closest pair problems, the task it is to find the two closest point among two point and a plan. Breath force methods comparing every possible pair of points and then select the minimum distance that this require comparison which become solve the largest inputs. Next one, traveling solvent problems. The traveling solvent problems require finding the shortest possible route that visits each city one and running returns to the starting in points. Using breath force all possible truth through checking which is rated up to factorial complexity of n-1. This makes breath force equations with the number of curves become large. Knobs of problem. The knobs of problem will involve to select a set of times which gives weight and values such that total weights does not exceed a limit while maximizing the total values. A breath force solution considers all the subsets of items which result is a time complexity of O to n. So this is only for the sample input. Assignment problem. The assignment problem involves assignment in a workings to the jobs in a way that minimize cost, maximize efficiency. A breath force approach there on n possible assignments, which is a computational differentiation for the large n. Therefore, more efficient algorithms like the human methods are usually performed. And the divide to conquer methodology. Divide and conquer is the powerful stages that break at a problem in similar subproblems solving each subproblem recursively and then combines the results into the final solution. This approach often led to much better efficiency compared to the brute force. Next one is merge sort. Merge sort is a classical example of divide and conquer the array in dividing into the helps. Each help is sorted regularly and then through two sorts. Levels array merges into single sort array. Merge sort has a content to the running of the O n log and is stable and release. Next one is quick sort. Quick sort works by the choosing a pivot element particularly the array into the two subarrays with elements less than and greater than the pivoted and receiving shortest the substrate. You sort the very fast and average will omega n log in time is pertain to the worst case is they can degraded to the O n values if the pivoted is not charging carefully. Next was binary search. Binary search applies divide and conquer to the searching in shortest arrays. The algorithm compares the target value to the middle element and the elimination halt of the search space to each step is reduce the time complexity to 1 log omega log n, which is a significantly faster and linear search. Next one, multiplication of the large interest. Multiplying two large integrations using two transition methods take O n square time division and conquer methods like is Kostopich algorithm split the numbers into parts and recursively computes products, reducing the complexity to about 1.585, which is much faster for large input. Next one, traditional material multiplication. Traditional material multiplication require O n data operation structures algorithm improves efficiency by dividing materials into substrates and reducing the number of multiplication from each of 7, 8 and 8 to 7, achieving a complexity of O n square 2.81. This method is fastly for large material but innovations more complexity implementation. Next one, breath force based division to conclusion. Breath force the every possible solution and if you simple to design but inclusion for the large input divide and conquer on the other hand systematically split problems into similar part leading to much better and sequence algorithm. Example including TSP and Knows-off for breath force and merge sort and binary search for division and conclusion. Next one is application for breath force. Breath force for commonly applied for the simple skull problems. Suppose solving cryptography throughout breath force attacks and sensors where the accuracy is essential and input size is manageable. Next one is applications of division and conquering. Division and conquering is a relationship used to a computer science. Example including short algorithm like merge sort and quick sort, searching methods like binary search, multiplication of large integration and material multiplication. It's also applied in computations grammar problems such as finding the closest pair of points. Next one, advantages to disadvantages. The main advantage of breath force is it is simplicity, but its merger talkback if references are divided and control prevents better efficiency and scalability, but can be complex to implement and has overhead to the receiving. Summary: breath force as a division of conquer to the two fundamental storage and in algorithm design will breath force precision the correctness but inflates division and conquer offer efficiency. Receiving solutions to many important problems. Understanding both methods helps to selected in the approach for the sensory. The fundamental of analysis and algorithm. Efficiency plus equal to time plus space. Time efficiency how too long it takes. Space complexity. Efficiency how much memory is used. Analysis is the need on the input size n, measuration by the counting number of basic operations like comparison, assignments, example வந்து linear search. The next one is space efficiency. Memory used during the executing fixed part, considered programming code, variable part, data structuring, recursive stock. Example வந்து research foundations requirement for space stock frames. So omega, theta. Next one other notations. Other notations the letter O equals stick upper bound faster than big omega. And then the letter omega stick lower bound better than omega. Clearly used in basic analysis. Next one time efficiency. Transitive efficiency. Z as a refractive, summative, additive, multiplicative. Next one. Analysis of non-research algorithm. Count operation line by line. Example, maximum element is array of size n equal to n minus 1. Comparison O n. Example, bubble sort. Next one, analysis of research algorithm. Used recurrent relation. Example 1, binary search. The example algorithm. Example 2, merge sort. The example algorithm. Research tree helps to visual algorithm. Next one, traveling salmon problem. The traveling salmon problem requiring finding the shortest possible routes that visiting each city one and returns to the starting point using breath force and possible route others checked, which led to facial complexity of n minus 1. This makes breath force imperative when the number of seats become large. Next one, knobs of problem. Next one, assignment problem. Next topic, divide to conquer methodology. Next one, myth shot. Next one, quick shot. Quick shot is the work by choosing a pivotal element. Partition the array into two subarrays, but subarrays with elements less than and greater than the private, and recursively shorten the subarrays. Quick shot is a very fast down array with time, but in the worst case it can degrade to them in not private in not choosing carefully. So advantage, disadvantage. The main advantage of breath force is the simplicity, but it is major drawback in influences the dividend and conversion, better efficiency and scalability, but can be complex with implementation and has a overhead to the receiving. So summary, breath force and divided to conquer are two fundamental storages in algorithm design. Will breath force grants to corrections, but it is a efficient divided and conquered to effort to efficient receiving solution to many important problems. Understanding both methods helps in selecting the right approach for different scenarios. So reference the content to derivative to further standarding algorithm textbooks such as Introduction of Algorithm by Kerman and Noye and Introduction to the Designing and Analysis and Algorithm by Anthony Lewis, also along with the next one. What is an algorithm? An algorithm is a fitness to step-by-step sequences that will define the instruction to the solve the specific problem or perfect task. List of two represent the good algorithm, fitness and definition. What is the first step in algorithm problem solving? Understanding the problem. Define computation the problem. The computation problem is a problem that can be solved using an algorithm involves to input-output transformation. What is meant by the problem instant? The specific input for the which what is meant by the problem instant? The specific input which is a computation problem need to the solved. Name two methods of algorithm design: divide and conquer, dynamic programming. What is the time complexity? Time complexity is a function that describes the amount of time an algorithm has to thermal of the sizes input and so on. Next one is the space complexity. Space complexity is the amount of memory an algorithm functions of the amount of inputs data typically denoted to by the n. What is the purpose of the analysis framework? To private to structure for the analysis for the efficiency, time and pace and algorithm. Next one, what does the analysis of framework consider? The input size, basic operation and number of time and basic operations executed. Next one, breath force. Breath force for algorithm design. Breath force is a structural methods for solving a problem by checking the possible solution executive. Name two advantages breath force algorithm. Two advantages of breath force algorithm are the similarity to the credited solution. There are easy to understanding and implement and the greatness are to find a solution and if and exit for the choice possible. One is the first one is simple to implement. Next one is often works well for sample input size. What is the closer path of problem? It involves for the fitness the power of point is with the shortest distance between them in a set of the point in the plane. What is the time complexity of the breath force is the closer per algorithm? The breath force approaches the complexity every pair of the n points to find the closest pair. The number of search compression. Next one is explorative search. Explorative search involves checking all possible combinations to find the optimal solution. Two problems are commonly solved by explorative search: traveling salmon problem, TSP and connoisseur problems. What is the traveling salmon problem? It is a problem of finding the shortest possible route that visit each city. So application divide to conclusive division and conclusive which will be used to computer size example including shortest algorithm like merge sort and quick sort, searching a methods like binary search, multiplication search. Search. What is the purpose of human coding? To grade optimal predictions code for data compression based on character references. What is the time complexity of human algorithm? Where is the number of characters? Give the example of a problem solved by the creative algorithm. Minimum spanning tree MSD problem. You want to connect all vertices in the weightless square with the minimum total edge weight and no cycle. Algorithm is a premium and curvature usually grades at each step to cycle or disconnect from the graphic. What is the time complexity of versus complexity? The algorithm use tree nest loops which running from 1 to n number of verticals. If update the adjacent the material to compute the transitive closure of the graph. This tuple time complexity makes suitable for the graph with a modern number of vertical. If you want, I can explain the algorithm step 2. The advantage and disadvantage. The main advantage of breath force is a simplicity, but it is major drawback. It influences divide and conquer private better efficiency and scalability, but can complex to the implementation has the overhead to discretion. Next summary: breath force and divide and conquer are two fundamentals struggling to the in algorithm design. Will breath force reduces the corrections, but it efficiency divided and conclusion affects efficiency receiving solution to many implementation problems. Understanding both methods helps in selecting the right approach for the sincerity, lower bound and algorithm analysis. If minimum amount of time researching environment and algorithm to solve problem, a tree that representative the sequence of the comparison or discussion made by the algorithm. How does decision to tree helps to preventing a lower bound? By shortening the minimum highest of the tree needs to distinction of the possible inputs which corresponding to the minimum time complexity. P in components complexity, the set of the decision problem that can be solving in the polynomial time, determination during variation. A problem is in a P if you 3 exact on algorithm that solves any instance of size n in time for some constants k. Thus problems are considered of efficiency solvable. The trouble to start finding the the shortest path of graphs. Extra this is an algorithm. Those to NP complete man. The class of decision problem that are both in NP and as hard as any problem in NP. So NP is a normal form of the definitions the problem in NP complexity. If the NP solution can be reduced to it is a polynomial time. Next one is optimization of algorithm. An algorithm decision to find the near optimal solution to NP complex problems in polynomial time. Expert solution for the NP problem are often computationally influenceable. Take exponential time approximation algorithm provide to good n solution quickly with performance, greatness, key factors on the greatness. So reference on the contents were debated from standard algorithm textbook searching introduction to the algorithm by the programmers. So reference books. Next one is hard problem to completion complexity. Problem that are believed not the have efficiency. Difference between the Knobs-Off and regressive Knobs-Off problem. Knobs-Off does not allow the splitting in times and factorial Knobs-Off allow the splitting. How does two optimization algorithm helps to the Knobs problem? I quickly find the solution closes and optimal when the exact solution are expensive. What is the decision tree in the context of a algorithm? A tree-based model that representation to the frequency of the comparison decision and the algorithm makes to solve a problem. Each internal nodes representative to the comparison to the decision. Each gets representation to the outcoming that decision. Next one, technical is used to solve the upset problem. It's a dynamic problem. The OPST problem, X capital, optical substitution, the optical tree constraints to optical subtraction overting. Optical tree is the constraints of overting. Substitutes the overloading substances substitution.